What is the difference between picking up a potato chip and a 200-pound weight? For humans, we might not think twice about the difference in dexterity, stiffness, and strength when reaching for an object. But for robots, the challenge posed by these differences needs to be considered. Yu Shi is a postdoctoral associate working on variable stiffness in robotic arms, trying to solve these challenges.
Sometimes we want the robotic arm to be stiff to do some particular task, such as carry a heavy load, position control, or force control. Sometimes we want the robotic arm to be soft for the purpose of safe interaction with the human operators or the environment. Accounting for the various scenarios our robots will encounter is the driving force behind developing variable stiffness robotic arms.
One of the largest challenges is finding the range from absolute stiffness to a loose, relaxed arm.
In order to do this, I studied the theoretical modeling of the variable stiffness arm and validated the modeling via commercial software. Based on the theoretical modeling, I identified the stiffness range of the robotic arm to effectively increase its safety. I also studied 3 different physical prototypes of the variable stiffness arms and collaborated with my colleagues to develop control algorithms to increase time efficiency for that task, and at the same time guaranteeing safety for the human operators, even if an impact occurs.
The ability for robots to collaborate safely with humans on actions is incredibly important because the tasks that these robots are working to aid or solve are in areas of hospitals, elderly care, grocery shopping, tasks that require arm strength, stiffness, dexterity that a human cannot do. In the future, Yu hopes to have multiple variable stiffness arms with increased capabilities to do more complex tasks and eventually have the robots become commonplace in society.